Everyone will get started in just a moment. Everyone a chance to filter in. All right, while everyone's filtering in, I will get some housekeeping out of the way. Hello, and thank you for joining us this evening. I'm Erin Driscoll. I'm the Adult Services Librarian at the Wilmington Memorial Library. We are in a Zoom webinar room tonight, which means that we won't be able to see you or hear you, members of the audience, but we do encourage you to participate in the chat feature at the bottom of your screen. A quick note before I introduce our presenter, we have some birch syrup samples available at the library at the circulation desk for pickup. Some of you have already picked them up. If not, no worries. We'll have them tomorrow and Saturday as well. So they're just at the first floor desk as supplies last. And I'm so excited to host and invite David Moore. This evening, he is a PhD candidate at the University of New Hampshire, where he studies tree physiology and syrup production. Prior to graduate school, he ran a successful birch syruping business, the Crooked Chimney, and his research is on syrup production from maples, as well as other species of deciduous woody hardwoods. So I'm going to turn it over to David.
All right, thank you so much, Erin. I really appreciate the invitation to speak. So I'm going to share a little bit about my research tonight. The biggest project I've done so far in my time as a graduate student at UNH has been this project to see if you can harvest sap and produce syrup from trees other than maples. And so it sounds like several of you have gotten a chance to taste birch syrup, which is great. See if I can advance my slides here. There we go. So as Erin mentioned, I used to be a syrup producer. I used to produce birch and sycamore syrup. And so when I approach my research questions, I generally come at them from kind of an applied perspective. So I just want to start off briefly by talking about maple syrup and how it's produced. I'm sure that many of you already know the process, but in the late winter and early spring, February and March, sugar maple trees are tapped. Little holes are drilled into them, and then you put a tap in and either hang a bucket, like in the picture, or you can run this extensive tubing system through the woods. And the goal is to harvest the sap that is inside the sapwood, the xylem of the tree. And in order for sap to run, you need a freeze-thaw cycle. So generally, the sap runs the best when you have, a day in the 40s and a night in the 20s, and it's, a nice, bright, sunny day. So you get a nice, strong freeze-thaw cycle, and that really builds up a lot of pressure inside the tree. So sap comes out, we harvest that, and then bring it into a sap house with an evaporator. That's the other picture. And so we use generally a combination of pressure and heat to remove all the water and concentrate the sap until it turns into syrup. So this is an evaporator it looks like it's a wood-fired evaporator. So they're using wood to heat up the sap and concentrate it until it turns into syrup. Now, so I mentioned before that a lot of my research is very applied, but it's also very, we say, basic science, which is more of like more the nuts and bolts of how things work. And so you may know that during the growing season, when trees have leaves, evapotranspiration is driving sap flow. So there's basically a water potential gradient between the soil and the atmosphere, and the tree's right in the middle of that. So for example, maybe the soil has a certain amount of water in it, and the atmosphere is a little bit drier relative to the soil. And so what happens is the tree is right in the middle of that gradient. And so water is entering the tree from the soil, flowing through this system of vessels and tracheids all the way up until it gets to the leaves. And then when it exits the leaves through the stomata, it evaporates and enters into the atmosphere. Now, the interesting thing is during winter dormancy, when all these deciduous trees like maples and birches don't have leaves, and so they're not transpiring in the sense that I just described, they still exhibit sap flows, right? That's why we're able to harvest the sap, is because we have sap moving up and down the tree, building up pressure. And so the other part of what I'm doing, this basic science question, is addressing this. So, the basic science question is, what environmental conditions drive this sap flow during winter dormancy, when there's no leaves, and why does it happen? What anatomical and physiological features in the wood, in the xylem, play a role in this process? And then, of course, there's the applied aspect, which is, can we harvest sap and produce syrup from trees other than maples and birches and walnuts? Maples, birches, and walnuts are sort of I would say at this point, probably the three most economically important and also well-studied trees for syrup production. Of course, maples are the most important, and then birches, and then walnut is not very common, but I know there's at least one producer who taps about at least 1,000 or more trees down in, I think, Virginia or West Virginia. So before we get into all these different kinds of syrup, I just want to talk a little bit about the methods we use in our lab. So this is my primary tool here. It's called a sap flow sensor. And you can see in the photo, there are three needles, three probes that we stick into a tree. And with this system, we're able to collect sap flow rates every 15 minutes for as long as they're deployed. Now, the way these sensors work is the top and bottom, the upper and lower probes are temperature sensors. They contain thermocouples. And the middle probe is a heater. And so from that middle probe, a heat pulse is emitted, a brief heat pulse is emitted every 15 minutes. And the top and bottom sensors basically just trace or track where in the tree that heat pulse is moving. And so if the sap is flowing up, then that heat pulse, that heat bubble, is also moving up. And so the upper temperature sensor will register a higher temperature than the lower one. And so from that sort of information, we can calculate how quickly it's flowing, how much sap is flowing, several different things like that. And alongside these sap flow sensors, we also collect a bunch of other environmental data like air temperature, soil temperature, precipitation, solar radiation, maybe soil moisture, all these different variables. And the purpose of that is we want to figure out what environmental conditions drive sap flow. So again, for example, with maples, we know what environmental conditions drive sap flow. You need a freeze-thaw cycle. But for a lot of these other trees, there's still a lot of questions around them, or no information at all. And then, of course, the practical side is we also, while we're collecting sap flow data, we're also tapping these trees and trying to harvest sap and produce syrup. Excuse me. So you can see here, in this photo, I've got a few, excuse me, a few beech trees tapped. And a lot of these trees, I'll talk a little bit more about this later, but a lot of these trees actually require vacuum pumps to harvest sap. With maples, you don't need vacuum pumps, although most of the big producers use them because you get more sap at no additional harm to the tree. So anyway, We use vacuum to help us harvest sap from all these different trees. And then I collect the sap, you can see in these little 5-gallon buckets, plastic buckets, food grade buckets, and then boil it all down into syrup. I kept separately by species, but you can see we've got 5 trees combined. You can see 3 of them here. So we take the sap, boil it down into syrup on propane burners with stainless steel pots until it reaches the proper consistency like maple. So I wanted to share some sap flow data with you, just so you can see what it looks like, and so we can even get a bit of a sense of how these environmental conditions drive sap flow. So this is American beech. It's a really common tree in New England, and in fact, it's thought to be very weedy. It grows like a weed in a lot of forests, a lot of sugar bushes. Sugar bush is a forest that's been managed for sugar maple for syrup production. So beech is sort of a weed, and it's not really economically important for very much. It's not great for lumber, but you can produce syrup from it. And anyway, so this graph that we're looking at here, there are 2 things going on. First of all, you see there are 5 different colored dots, and each different color is a different tree, a different sensor in a different tree. And those dots represent sap flow rates. So the unit for this is sap flux density, you can see on the left, which is it's basically just a volume of sap flowing through a given cross-sectional area of wood per hour. And we call that sap flux density. So it's basically just sap flow, are those 5 different colored dots. And then overlaid on top of that, I also plotted air temperature, which is the thin black line. And you can see the daily cycles when the temperature increases in the day and then decreases at night. And I also plotted, just for reference, hopefully you can see that thin red dashed line, that horizontal line, and that is at 0 degrees Celsius, which is the freezing point of water, 32 degrees Fahrenheit. Now, pay attention to something on this graph. You'll see on the left side of the graph, the air temperature is pretty consistently above freezing. And you also don't observe any sap flow. But over on the right side of the graph, you have freeze-thaw cycles, right? So in the night, it goes below freezing, sometimes considerably below freezing. And then during the day, it spikes above freezing. And when that thaw happens, you can see these pretty big spikes of sap flow. And so the conclusion based on this graph is that freeze-thaw cycles also appear to drive beech sap flow, kind of like they do in maples. And I'll just show you one more. This is London plane tree, which is an ornamental species, but it's also very closely related to the American sycamore, which is a pretty common floodplain species in southern New England. And it also happens to be, out of all the different syrups I've tried, I think this is my favorite, sycamore syrup. And you can actually kind of see the same type of patterns happening here. So on the right side of the graph this time, the temperature is pretty consistently above freezing. It doesn't dip below freezing, and there's very little sap flow. But on the left side, there's several freeze-thaw events, and each one is associated with a sap flow event. So now I want to shift gears and talk about actually producing syrup from different types of trees. So each of these species that I'm going to go through has sort of these little quirks or nuances that make syrup production a little bit different and maybe even a little bit more challenging than it is for maples. And so I already kind of explained how maple syrup is produced. And now I'm going to talk about how all these different types of trees, how you need to, the differences from maples in processing the sap into syrup. So we'll start with birch. I'll kind of go in order of their economic importance. So birch is the second most important one. It's very commonly produced in Alaska and Canada, mostly at latitudes, above where sugar maples can't grow anymore. But it's also, I think there are probably about half a dozen birch syrup producers in the Northeast, or even just in New England, maybe. So birch sap starts to run basically right when maple sugaring season is ending. I remember when I was producing birch syrup, someone I was living with was making maple syrup, and for those few years we were making syrup together, he would basically pull his maple taps out the same exact day I would put my birch taps in. So you don't have much of an overlap. Birch sugaring season is shorter, much shorter than maple sugaring season. So maple sugaring season is like 6 to 8 weeks. It starts in like early to mid-February and goes until mid to late March. But with birch sap, you only get runs for about 2 to 3 weeks at most. Now the reason there's not much overlap between maple and birch sugaring seasons is because birch is not driven by freeze-thaw cycles. Birch actually requires a little bit warmer temperatures. So the best sap flow days for birch are like nice sunny days in the 50s, maybe as much as 60 Fahrenheit. And you also don't need a freeze. So generally by that time of the year, nights are in the 30s, maybe a little bit of a freeze, but anywhere in the 30s is sort of what I associate with birch sugaring season. Birch, like maple, is one of the few species that you don't need a vacuum pump to harvest birch sap. They build up enough pressure inside the stem that you can just drill a hole and it will start dripping out. Now, as I mentioned before, there are some little quirks about all these different species. And so really important with birch is that you should only use plastic and stainless steel equipment for harvesting and storing and processing sap into syrup. Glass bottles are fine. Now the reason for that is birch sap it's quite a bit more acidic than maple sap, and it will actually dissolve different types of metals like aluminum, copper, galvanized steel, and what ends up happening is when those type of metals come into contact with birch sap, they impart a really, really, really awful, really terrible, unpalatable off flavor on the sap. And so often you hear of people who are just trying to make birch syrup for the first time and it tastes really bad. And this could be the culprit, because a lot of maple sugaring equipment is, for example, aluminum or galvanized steel or copper. And so you can't necessarily just switch over to birch. You need to sort of take into account. Now, I didn't really talk about this earlier, but I'll bring it up now. Most maple producers use what's called reverse osmosis, and you may be familiar with this from, you may have a reverse osmosis system underneath your kitchen sink to filter your water. And basically what it's this ultra fine membrane that only water molecules can pass through, and anything bigger than a water molecule, like a sugar molecule, can't pass through. And so what it does is it pressurizes water and forces it through this membrane. And so what happens is you get pure water on one side and then what's called concentrate on the other side. And of course, for your kitchen sink, you're interested in the pure water. But sugar makers are interested in the concentrate. They want to remove the water. And so they'll concentrate maple sap from like 2 or 3% sugar up to maybe 8% or 14% sugar before they even put it in their evaporators. And it's good to use heat also to process sap, even though it's more energy intensive than reverse osmosis. But it's nice to generate those nice, caramelized flavors and the darker colors. But with birches are I'll talk about birch sap briefly. So birch sap contains different sugars than maples. Maple sap contains sucrose, table sugar, basically. It's a disaccharide. And birch sap contains mostly, it contains a little sucrose, but mostly fructose and glucose, which are both monosaccharides. And fructose is probably the most prevalent one in birch sap. Now, the thing with fructose is that it actually will scorch at somewhat of a lower temperature. And so if you just kind of heat the heck out of your sap like you would with maple, birch syrup may actually end up tasting a little burnt because of what's happening to the fructose as you do that. And so you should kind of be a little more cautious with your temperature. Although using reverse osmosis systems, you can concentrate your sap so much without using any heat at all. And so by the time it gets into the evaporator, that may not be as big of a concern. So the next bullet here, with maples, sugar maple is the best maple tree to produce syrup from. You can produce syrup from any maple, anything in the genus Acer, but sugar maple is the best because the sap is already pretty sweet. You don't have to concentrate it as much as you would have to concentrate, for example, red maple sap, which is a lot more dilute. So paper birch is kind of the sugar maple of the birches. It's got a much higher sugar content than at least the two other birches that I've worked with before, yellow and black birch. But that being said, overall, birch sap is much more dilute than maple sap. And so I say paper birch is the sugar maple of the birches, but really you're from a paper birch, you're only getting like 1 or 1.2% sugar in the sap, whereas with sugar maple, you're getting 2.5 to 4% sugar. But still better than the other birches. Yellow and black birches are about half as much as sugar maple, so maybe 0.5 or 0.6% sugar on average. So really, really, extremely dilute in those other birches. And the one other interesting point I can bring up about birches is that you may be familiar with the oil of wintergreen scent on yellow and black birch bark if you scratch the bark a little bit and smell it. But unfortunately, that wonderful, desirable smell does not end up in the finished syrup product because it's very aromatic. It's volatile, and as soon as you heat it up in the evaporator, it volatilizes and it doesn't end up in the sap. So I think that's all I want to say about birches. I'll talk a little bit about walnuts now. I know you guys don't have any walnut syrup samples, but I can tell you that it tastes a lot more similar to maple than birch does. I would say maybe a little smoother, a little nuttier. And it also runs at the same time as maple sap. It's got that same temperature-driven process that maples have. The one quirk about walnut, though, is that walnut sap contains a lot of pectin. Pectin is a plant defense compound, and when you drill that tap hole into the tree, pectin is one of the compounds that the tree uses to wall off that hole, that wound to the tree. And it ends up, a lot of it gets into the sap that you harvest. And so when you remove about half of the water, all of a sudden you get this pretty thick film of pectin on the surface. And this pectin is like the bane of a walnut syrup producer's existence. They struggle with how to take care of this because you should really filter it out, but it gums up the filter so readily. And so it's a big challenge for walnut syrup producers. And walnut trees are the third and last tree that you actually don't need a vacuum pump to harvest sap from. They also generate enough stem pressure, we call it, to be able to harvest sap. We say by gravity, which it means without a vacuum system. So next are the beeches. I talked a little bit about these before. It seems like in general, I would say beech season and maple season are pretty similar. You do need a vacuum for beech. Beech syrup also tastes, I would say, pretty similar to maple. Beech sap is really dilute. I made some beech syrup last year, and the sap, I think on average was like maybe 0.5 or 0.6% sugar. And it took, I want to say, like 160 gallons of sap to make 1 gallon of birch syrup. Sap to syrup ratio is sort of a common metric that we talk about in the syrup industry. And beech, I would say, is probably maybe the fourth most economically important syrup. I know of one beech syrup producer in upstate New York. And so that's starting to catch on a little bit. And next is sycamore. I talked about this earlier too. I've had one experience in my life when I was able to harvest sycamore sap without vacuum. I think it was sort of an anomaly because when that happened, I went back the following year and set out many more taps and didn't harvest any sap. But more recently, when I've started to incorporate vacuum pumps more, you can harvest sap from sycamore trees pretty reliably during the same season as maple. And so one little quirk about sycamore is it's got the same exact problem with birches in that you need to use stainless steel and plastic equipment. And also glass bottles are fine too. I remember I ruined I was boiling down some sycamore sap once, and all of a sudden it started to taste really bad. And I was wondering what it was, and my friend tried some, and we realized that I was using an aluminum pot. And so sort of just to be sort of cautious these days, I just use stainless steel and plastic equipment for everything, regardless of what species it is. But of course, eventually we'll want to figure out which species that's required for and which ones it doesn't matter for. And of course, a vacuum is I would say pretty much required to harvest sycamore sap. We've tried lots of different other trees, basswoods and hophornbeams and ash and hickory, poplar. Most of these have been unsuccessful, even though A, I'm using vacuum, and B, we are tapping these trees, sort of all throughout the dormant season. So we're trying to capture all the different possible environmental conditions that could drive the sap flow. I know two folks who have produced basswood syrup in the past. I just, for whatever reason, haven't been able to figure it out for myself yet. Hophornbeam, I will briefly talk about hophornbeam. It's in the birch family. Sap runs, it's a small, sort of nondescript understory species. And it sort of has, it also runs very later in the dormant season, sort of around the same time as birch, I guess. And I've harvested sap from that, but just not quite enough to produce syrup from it. So I think next year I'm going to try to tap more trees and get enough to actually produce some syrup from it. I do a lot of firewood, and I remember one year we had a couple freshly cut ash and hickory logs down on the edge of a hayfield, and I noticed some sap bleeding out from the ends of them. This was in like January or February, just above freezing, maybe in the mid to upper 30s, and I tasted them, and they were very sweet, and so that inspired me to pursue ash and hickory. But so far I haven't been able to harvest sap by tapping these things. And then sap flow sensors, going back to the sensors now, I've sort of been, each year I'll do a handful of new species. So we've done several different species. of sap flow data, and that'll at least allow us to see what environmental conditions are driving the sap flow patterns in these species. I included a picture of hardy kiwi, or kiwi berry, as Iago Hale, who does kiwi berry research here, calls them. And kiwi berries, they're vines. Well, they're technically vines because they sort of twine their way up trees, and instead of having tendrils like grapes do. But both grapes and kiwi berries, you prune them before they bud out in the spring. And when you're pruning them, both grapes and kiwi berries always have a lot of sap that comes out. And so who knows if you can be able to harvest that sap and produce syrup from them. But maybe someday I'll try to actually do that as well. So I've talked about sap flow data, and I've talked about doing, tapping trees and harvesting sap and producing syrup. I want to talk about some of the next things we're working on now. I've been working with somebody at UNH to try to identify all the different chemical constituents of these new saps. And of course, it'll be interesting to see what health benefits, if there's any medicinal benefits to these new saps and syrups. And of course, we want to be cautious to see if there's anything poisonous as well. But also the other thing that I can point out is that if you remember with, for example, walnut, there was pectin. And so the chemical constituents of the sap may inform how you have to process it. And while I'm on this slide, I'll just make one more point, which is when you process sap into syrup, the chemical, like all the different molecules that are present in the sap initially, don't necessarily end up in the final syrup product. And there's two reasons for that. The first reason is that when you heat it up, that causes different chemical reactions that can change things. And the other thing that happens is, and of course, volatilization can happen too. If you have, for example, the oil of wintergreen I talked about volatilized and doesn't end up in the syrup. But the other thing that can happen is that as you remove more and more water, there's less water around to dissolve everything that was originally in the sap. And so what happens is at certain points, you remove more and more water. At certain points, there's just not enough water around to dissolve everything in the sap. And so stuff starts to, we say, come out of solution or precipitate. So for example, stuff that's not very water soluble, it was in the original, dissolved in the original sap, but it's just not as soluble as sugar and stuff. And so as you're removing water, at a certain point, there's just not enough water to dissolve everything. And so the insoluble things come out of solution, they precipitate, and they can either form a little crust on the bottom of the pan, or maybe like a foam or a froth on the surface. And we call that sugar sand or niter. And that's something that's important to filter out at the end. So anyway, the point being is that sap and syrup generally have slightly different, or maybe even vastly different, I'm not sure, chemical compositions. And so we'll analyze both the sap and the syrup when we do this. And the one other thing that we're working on right now is we're looking at how these trees respond to wounds. And so I included here a picture of tap hole lumber. This is a sugar maple tree that has been tapped repeatedly and then milled into these nice looking boards. And you can see, if you look closely, there are black dots. Those are the tap holes. And then above and below the tap holes are these streaks, these sort of columns of dark brown wood. And those columns of dark brown wood, we call those columns of non-conductive wood, because basically what happens is when you tap a tree, you drill a hole into a tree, you're severing all these xylem vessels, all these hydraulic conduits that move water up the tree. And when you sever those, they no longer function to move water. And what happens is the tree starts to wall them off from the rest of the plant, to compartmentalize them, so that for example, any pathogens, fungi that enter through the tap hole can't spread to the rest of the plant. The plant also wants to be protected from air bubbles from getting into the system and causing blockages. We call those embolisms. So the tree compartmentalizes these wounds, and you get these columns of non-conductive wood above and below tap holes. You can see here that in sugar maples, they're pretty significant. They extend, it's pretty variable, but they could extend, maybe as much as a couple feet above and below the tap hole. In paper birch, they actually extend very, very far above and below the tap hole. So paper birch, you may want to be a little bit more conservative when you're tapping paper birch, because each year when you install a tap hole, you're going to lose quite a bit more conductive tissue than you would on sugar maple. And so we're replicating this study on all these different trees that we're tapping to see how well they respond to wounds, and hopefully ultimately this will inform tapping guidelines when we start to if and when we start to tap these other trees commercially for syrup. So that brings me to the end of my talk. I just want to briefly acknowledge the different organizations that have funded me. Northeast SARE, the New Hampshire Agricultural Experiment Station, and also the UNH Core Initiative have funded all the work that I've talked about today, as well as a lot of my colleagues and friends and mentors and family. I'm really appreciative of all their help as well. And so I guess lastly, I just like to say, if you ever have questions about this, or you end up trying to produce any of these different types of syrups and have questions or want to share your experiences, I'd love to hear from you. So please let me know how that goes. And thank you so much. And I look forward to your questions.
Excellent. Thank you, David. Yes, if you have any questions, if you would like to enter them into the chat feature at the bottom of the screen there. And I will also make sure to link to David's website and Gmail in our follow-up email from this evening. Let's see, Lisa had a question that she hadn't thought about possible damage from the actual tap holes. Wondering if you have to be careful not to take too much sap from a tree, or is it self-regulating? Do the trees only release a certain amount?
That's a great question. So the answer to that question is, there was a study that was done maybe about 7 years ago now, and they were measuring growth rates, radial growth rates, so not height, but they were measuring how much girth does a tree put on every year. And they compared trees that were never tapped, trees that were tapped using vacuum, and trees that were tapped without vacuum. And what they noticed was trees that were never tapped grew much more quickly. But there was no difference between trees that were tapped with or without vacuum. And so basically, the conclusion is that the tap hole wound is what is reducing growth. The amount of sap that you harvest really doesn't have much of an effect at all, and so that's why we're fairly confident that using vacuum doesn't harm trees at all. Additionally, it's just the tap hole wound that causes the damage, and so that's why it's important to follow tapping guidelines. Only put one tap in a tree up to a certain diameter, so on and so forth.
Christine has a question. Does the vacuum pull sap from the tree, or remove more from the tubing itself? How much additional sap does the vacuum produce?
So first of all, you can only pull a vacuum on gas. You can't pull a vacuum on liquid. So what happens is, as you remove air from the tubes, then liquid moves into that space. And could I just take a peek at that? I'll click on, here we go.
Oh, sure.
So does the vacuum pull sap from the tree or remove more from the tubing? So it does pull sap from the tree. And if you think of the tree as having all these hydraulic conduits going up in all different directions and connecting and going apart, coming together and moving apart. What happens when you introduce vacuum is all of a sudden you're basically just expanding the amount of sapwood that you're harvesting sap from. So these vessels that are connected, maybe without a vacuum, you're just harvesting sap from right around the tap hole. But with a vacuum, now you're getting things that are farther away but still connected. And how much additional sap does a vacuum produce? I actually don't remember off the top of my head, but it's pretty significant. I want to say at least 1.5 or 2 times, but I'd have to double check on that. I should know that, but that's a good question.
Excellent. Christine also would like to know, can I try tapping a tree in my backyard without investing in lots of equipment?
Yes, you certainly can. The first year I ever made syrup, I had a little pot boiling on my wood stove. And so you can certainly just tap one tree and use a pot on your stove, although you'll have to be prepared because your kitchen will be very humid. And I think some people sometimes have wallpaper peeling off, and I would hate for that to happen to your house. But yeah, you can buy, just maybe 1 or 2 taps, 1 or 2 buckets, and, maybe just use a propane burner out in your garage or something. And that's certainly sufficient for that. Yeah.
It sounds like you'd want a stainless steel instrument if you were going to try different trees than maple, right?
Yeah, with maple, it doesn't matter. But yeah, for birch and for sycamore in particular, I would certainly suggest stainless steel and plastic equipment. Yep.
Joanne would like to know, what is the ratio of maple syrup harvesting versus all the others, and why is only maple on the market for consumers?
Yeah, so I mean, the maple industry it's huge. It's just so much bigger than any other syrup industry, although birch is decently big. So I will say that there are some birch syrup producers in Canada and Alaska that are tapping thousands of trees. I believe the biggest producer is in Alaska, and I believe they're tapping hundreds of thousands of trees, I think, as of my last check. But I believe that the reason maple syrup is so much more widely available and economically important is because it tastes great. Birch is a little less sweet. I almost think of it as a little more of a savory thing, but maple is just so sweet and has such a pleasant taste. And also B, the trees, the season's much longer. The sap is much more concentrated already, and so it's much easier to produce maple syrup. And I certainly think I like to think of all these different trees that I'm studying as maybe supplementing or providing additional income sources, but certainly never overtaking maple in the marketplace.
Frank has a question. Sometimes in his homemade syrup, he gets a light, fluffy material. Is that one of the materials that are not soluble without water? He filters it through a cheesecloth.
White, is that like can I ask a question of Frank? Is that like a foam or a froth that develops on the surface? I'm guessing. Yeah, so that's what we would call sugar sand, and you would filter that out. And you even in the industry, people will use either some commercial synthetic defoamer or even just butter. Any oil-y substance works, and if you just take a knife or something and swipe it through the pan, all that stuff goes away. But yeah, that's stuff that should get filtered out. Exactly, it's sugar sand, some precipitates that came out of solution.
Oh, he says no, in the syrup itself after bottling.
Oh, okay. So that's a good question. So when you're processing sap in the evaporator, it's very hot, and then you bottle it. It also has to be hot when you bottle it because you want a good vacuum seal in your bottle. But then you let it cool down, and when it cools down, there's a chemical principle that basically hot water dissolves more things than cold water. And so as things cool, it's less able to dissolve everything that was in there. So often you see, for example, maybe sugar crystals or something like that. But there could be other things in there as well that they're just coming out of solution as it cools. I'm not sure what the light fluffy things are, but that would be my That would be my guess.
Sure. I was wondering if you've noticed, since it is something kind of dependent on temperatures and weather, has there been a shift with climate change or, changes in the season? Have you noticed the season happening earlier in the year, later in the year?
Yeah, so again, maple sugaring season depends on freeze thaw cycles. So if that is shifting earlier in the year, then absolutely you'll get. I've noticed, I think the past couple years that window of time when you actually get those freeze thaw cycles is a little bit shorter. I'm not sure if this is a trend that will continue, but so that can certainly impact how much syrup is produced each year. So that's directly related to the economics for a syrup producer. There's always technological improvements, and so sometimes it may be a terrible year weather-wise, but if you just upgraded to a new piece of equipment or something, that could offset a little bit of that. But yeah, in general, I mean, it's certainly a concern in the industry. Sugar maple as a species, I think right now is doing pretty well, but of course, if this trend continues and sugar maple maybe gets outcompeted on a lot of the land that it's on now, then certainly in the distant future, that'll be a big concern for the industry as well.
Excellent. Another question I had is sometimes I'll see syrups described as like a first run syrup or like a later in the season syrup. Is there like a taste difference depending on when the sap was harvested, and why would that be?
Yeah, that's a very good question. That's something I don't know too much about. I'm guessing there are some differences in the chemical composition of the sap as it comes out of the tree. However, I do know that as the season progresses, at the beginning of the season, you install all your equipment and you've just cleaned it, and so it's perfectly almost sterile. And as the season progresses, you have microbial communities that start growing maybe a little bit on the inside of the tubing, in a dip in the tubing where you get sap that collects, or so these microbes are actively eating the sugars and breaking them down, and so they're doing a little bit of fermentation, all these different things that will certainly alter the taste and the color. And also, sorry, I'll just add one more thing to that. The longer that you heat your sap, the darker it will become too. So maybe in the early season, you're processing everything right away, and the first couple batches you pull off you've processed into syrup very quickly, and so they don't develop that darker caramelized color as much as later stuff. Oh, I think you're on mute.
Yes, I was on mute. Another question I feel like I would be remiss without asking, do you have a favorite syrup you've tasted so far from these trees?
Yeah, I think for me it's sycamore, but my friend Mike, who is the beech syrup producer I referred to earlier, he was telling me his favorite. He's probably tasted a lot more different types of syrup than I have, and he told me that his favorite is from a tree called yellowwood. It's in the pea or bean family, and so that's one that I'm keen to try sometime as well.
Nice. And we have the birch samples available for the registrants tonight. I tasted one. It does taste a little savorier. Is there, having been a birch syrup producer, are there any recipes or uses you usually recommend for birch syrups?
Yeah, I like to. You could use it in the same way as maple, just recognizing that it's a little more sweet. It tastes a little different. It's my favorite thing is on ice cream. My mom likes to put it in her coffee. You can cook with it like molasses. You can use it as a glaze on red meat or salmon. You can mix it with like balsamic vinaigrette and olive oil to make a really nice salad dressing. So there's a lot of different uses for it.
All right. If anyone has any last questions, you can put them in the chat. I'll just check our Facebook watchers. No questions there, but Lauren would like us to know that is fascinating stuff, and she'd like to thank you for doing this presentation, David. I'd like to thank you as well. I've certainly learned a lot. Lisa also thanks you.
Thank you, everybody. I really appreciate the opportunity to speak, and thanks, Erin, again for reaching out to me.
Well, thank you. And again, I'll include David's email and his website in the follow-up email tonight. We have the syrup samples if you're curious at the desk at the library. And thank you all for joining us this evening. Have a good one.
Thank you.